Hello beautiful people and welcome. In this video we are going to be reviewing everything absolute value, specifically graphing and solving equations. As always, I am human, so if I make a mistake, please let me know where the mistake occurs so that way I may fix it and we both can learn from my mistakes. Let's start off with graphing. I will be referring to my little graphic organizer cheat sheet here. So for graphing, we have these steps. So step number one for graphing is to write it in the form of g of x. It could be f of x, q of x, it doesn't really matter. But if we have g of x is equal to a, now a is going to be outside the bubble, if you're in my class, outside of the function, which means you're going to either stretch or compress vertically. B and h, I would say think the opposite. So if you see a fraction, you're actually stretching something horizontally. If you see a whole number, you're actually compressing it horizontally. H, I always say think of the opposite of what you see. So for example, if you see a -3, H is in fact +3. And H represents your horizontal shift. So if you see a -3, you're not actually going to the left for -3, you're actually going to the right for a +3. K is outside of the bubble or outside of the function, and it is exactly what it is. So if you see a +5, you are shifting 5 up horizontally, vertically. Since it is outside the bubble, we are doing vertical. So once you have it in this form, you're going to identify your vertex. So your vertex is h comma k. And again, h is always opposite of what you see. So if I see a +5 for h, then it would be a -5 for my h value. Then we're going to create a t-chart with the vertex being in the middle point. Then step number 4, we're going to choose the pretty value. Now pretty is in bunny ears or quotations because it's not really pretty, but we basically want to make sure that the x value is chosen very strategically to give you something for y that you can actually graph. And step number 5 is graph. So let's do that real quick. Step number 1 is we want to make sure that we have it in our form, g of x. Let's actually change my marker here so you can see it a little bit better. Instead of a pencil, we want g of x is equal to a absolute value of 1 over b of x minus h, parenthesis, absolute value, plus k. And it kind of does look like everything is good. We don't have g of x here, we have y. It's okay, it's kind of like the same thing. I don't have an a value, so a is here. If you don't have an a value in the front, that just means a is 1. I have my absolute value, then I have my b, right? I don't have a number, I don't have anything in front of x, so that means b is 1. And then I have x minus 2. If you did have a number in front of your x, I'll show you how to take care of that here in a little bit, minus 3. Alrighty, so here we go. Here is our h. Here is our k. Now remember, h is always opposite of what you see. So if I see a -2 here, it's going to be a +2. K is exactly what you see. So if you see a -3, k is -3. So your vertex is going to be 2, -3. Step number 1 and 2 we already did. Step number 3 is create a t-chart. Let's do that here, so that way I have some space on the other side to graph. Here's my x, here's my y. You're going to put your vertex in the middle, so 2 and -3 is in the middle. Now, step number 4 is you want to choose your pretty points. You want to choose x values that give you something pretty in return, and you want to solve for that. For example, I can choose 37 for x, but 37 would probably not be a good choice just because I most likely don't want to graph up to 37 for my x values. So I'm going to choose something like 0, 3, 5. If it's a fraction, I want to get rid of the fraction. So I'm going to choose 0. If I choose 0 for my x value, 0 minus 2 is -2. Let's actually do that off to the side. Let's do that in a thinking bubble. If I have y is equal to x minus 2 in my absolute value, -3, and I choose 0 for my x value, plug it in, we're going to solve, that's absolute value of -2. So absolute value makes the number inside positive. So that means we have 5 is our answer, but let's actually do that as a step process. So 2, oh, not 5. I'm glad I did the step process. 2 minus 3, which is in fact -1. So when x is 0, my y is negative 1. Now there is a mirror image on graphing absolute value. So you will have another point where y is negative 1. You can choose to do so, graph first and then figure out where that point is. Or you may choose to do a different x value and just see where it leads you. So if we do another x value, let's just randomly choose one. Oh, I don't know. Let's do 4. We want to choose one x value that's smaller than our vertex and larger than our vertex x value. So if we do 4, here's another thinking bubble. So if we do another thinking bubble, we have y is equal to the absolute value of x minus 2 minus 3. Plug in 4 minus 2 minus 3. 4 minus 2 is 2 minus 3. Absolute value of a positive number is still positive, so I have 2 minus 3. Therefore, I have negative 1. And it's just happy accident that I ended up with negative 1 as well, because I randomly chose my number 4. But here you can see that we are going to have a negative 1 as my y value and another negative 1 as my y value. So let's go ahead and quickly sketch this out. I'm going to change my color just to make it a little bit different. So I have my vertex at 2 and negative 3. So here's 1, 2. Here's 1, 2, 3. Vertex is here. Then I have 0 and negative 1, which is here. And I have 4 at negative 1. Now, when you're graphing absolute value, it will give you a shape like a V. So make sure that you are giving me a sharp point on the vertex. Arrows are required here because this is a continuous function. So that means it will continue in both directions for infinity and beyond. All right, continuing on with example number 2. Step number 1 is to get that into the g of x form. Now here we have f of x is equal to this equation. We can leave it in terms of f of x. It doesn't matter. So let's identify what we have. Here we have this negative out in front. That means we're going to have a reflection across the x-axis. That means it's going to be flipped over. Then we have this b value, which again is still a negative, so I'm going to reflect it not only with my x-axis, I'm also going to be reflecting it with my y-axis because I have a negative here. This 3 is our 1 over b, or our b value. Here's our h value, and again, opposite of what I see. And then here is my k value. Now, I do want to be careful, so I'm actually going to cross this out. Notice that I do not have parentheses. So if we go back to our general form, I need x minus h in parentheses with the b factored out, or the 1 over b factored out. So negative 4 is in fact not our h value. Negative 4 is part of this negative 3 that's been combined. So we want to separate them. We want to separate this negative 3 from x, and we want to remove that negative 3 from our negative 4. So how do we do that? Let's go ahead and do a thinking bubble off to the side. So I'm just going to focus on that negative 3. I don't even care about the absolute value just yet. I need to factor out or remove that negative 3 from my x and my 4, my minus 4, my negative 4. If I remove this is kind of like undoing our distribution. If we had distribution, if I was to multiply negative 3 times x, I would get my negative 3x. If I was to multiply negative 3 by something, I have to get a 4. So how do we figure out what goes in here? Well, you're going to set up a mini equation. And that mini equation goes like this. Negative 3 times what, you can call it, let's call it w for what, is equal to our 4. Now you can choose to do negative 4. Just be careful doing that. So negative 3 times what is equal to 4. So I'm going to, since I have multiplication, I'm going to divide by negative 3. So w, I ran out of space. It's okay. W is now equal to 4 over negative 3. So 4/3. But it is negative. So what's going to happen is in here, right here, that's where this will go. We're going to go back in. So negative 3 times 4 over negative 3 will give us a negative 4 as our answer. So I'm going to rewrite this in our general term. I'm going to keep it in terms of f of x. I'm just going to shift it over to my left side. So I have f of x is equal to negative 2 times the absolute value of, now this is where it's going to be a little different. This is what I'm going to write. I'm going to write negative 3 times x minus 4 over negative 3. Now since both of these are negative, I'm going to choose to make them positive because a negative times a negative is a positive. Two negatives make a positive. And we have our absolute value and our k value. Now, that should be a 1. That should be a 1. We know what k is. So that means now that negative 3 is pulled out, that's going to be our b value. That's going to be our 1 over b value. Excuse me, it's always the opposite of what you see, right? So then, here's our k value, which is negative 1. Now our h value is now going to be a negative 4/3. Again, we had two negatives next to each other. Let's do it one more time here in a thinking bubble. This is what I had. I had negative 3 of x minus a negative 4/3. This 4/3 came from this equation. Two negatives make a positive. Therefore, I have negative 3 times, or negative 3 of x plus 4/3. Since I have a positive now as my 4/3, my h value is actually going to be the opposite of that, which is a negative 4/3. Now that we have our h value and our k value, we know what our vertex is. And I'm actually going to start with my t-chart, kind of start combining our steps. And our vertex is negative 4/3. K value is negative 1. Now, you can go ahead and plug in your other two numbers here in the original equation, or you may choose to plug it in here as well. It's your choice. I'm going to choose the original to plug in to find out my other 2 points, just because I don't want to deal with a fraction. We already dealt with the fraction as our vertex. So I'm going to use this one here, thinking bubble. It'll be easier for us to solve. I'm choosing pretty numbers. 2, we can do 2 if we want. It doesn't really matter. I'm going to multiply by 2. Hopefully that will give me a nice small number, nothing too large. So I have negative 2 times the absolute value of negative 3 times 2, which is negative 6, minus 4, absolute value minus 1. Negative 2 times, this is 6, 7, 8, 9, 10, so negative 10 minus 1. This is the absolute value of 10, so I have positive 10 now. This is negative 20 minus 1, which is a negative 21. So not too small. We may want to choose a different, smaller number. I am already in my negatives here, so perhaps we want to choose a negative number for our next one. Let's try here. Hopefully that's enough space for me. So what do we have? We have negative 2, absolute value of negative 3. Let's choose something small. Let's choose 0. I don't know why I didn't choose 0 before, and then we can try a negative number after that. So 0 times negative 3 is 0. 0 minus 4 is still 0. That should be a 2 here. I apologize. So I have negative 2 times negative 4, absolute value, minus 1. Negative 2, absolute value of 4 is positive 4, minus 1. This here is negative 8 minus 1, better. So we got a negative 9 as our answer. So if we choose 0, our answer is negative 9. So we did have 2 points. I have 0, 2, but I still don't have a negative. Remember, we want to choose one that's above your x value vertex, and we want to choose one that's below your x value vertex. So let's choose one that's below. Let's do random number, but we want to keep it small. Why don't we do a negative 1? We plug in negative 1. See what that gets us. Running out of space, I'm going to choose to write on a different sheet of paper here to plug it in. So I have a negative 2. Oh, you guys can't see that. Let's change it. Negative 2 times the absolute value of negative 3, x minus 4, minus 1. We decided to do negative 1 as my input. Minus 4, minus 1, negative 2 times. This is negative 3 times negative 1. That is a positive 3, minus 4 still left over. Minus 1 is also left over. Negative 2 times 3 minus 4, that is a negative 1, minus 1. Negative 2, absolute value of negative 1 is a positive 1. So I have negative 2 times 1 is negative 2 minus 1 is a negative 3. So if we input negative 1, our output's going to be a negative 3. Now the only thing left for us is to graph. Let's go ahead and sketch this out. I do have some space here. Alrighty, so we have our vertex at 4/3. Now 4/3 is saying I have 3 over 3 and I have 1 over 3. So that's basically saying I have 1 and 1/3, but on the negative side. So we're going to guesstimate what that is. So we want it on the negative side. Oops. Alrighty, so what do we have? We have 1 and 1/3. So here's 1. 1 and 1/3 is about here-ish. And we have that y value at negative 1. So our vertex is going to be around here. Next we have 0 and negative 9. 0, 1, 2, 3, 4, 5. I am very much short on my y value negative. So 1, 2, 3, 4, 5. 6, 7, 8, 9. So 0 and 9. I have one here. And then I have one at negative 1, which is negative 1. And I have one at negative 3. So you guys notice something. I don't have a V. If I was to connect these, I only have one side. What really happened is when I chose negative 1, I didn't really choose something smaller than my vertex. My vertex is 1 and 1/3. But I chose 1, which was a little bit smaller. So now let's go ahead and do this one more time for the value of 2, so I can get another point on the opposite side. So if we chose 2, as my input, let's do negative 2, excuse me. Oops, that should be an absolute value. This should be a negative 6 minus 4. This should be a positive. Negative times a negative is a positive. So I have negative 2. 6 times 6 minus 4, that is 2. Positive 2 minus 4. This is still positive. So I have negative 4 minus 1, and that's going to be a negative 5. So I have 2, negative 5, 1, 2, 3, 4, 5. So here it is. Now we're going to combine. You can use a ruler. I encourage you to use a ruler. I'm going to just guesstimate my sharp lines here. So again, vertex is here. We want 2 points minimum. In this case, we ended up having to do a little bit more just because it's more of a challenging question or a challenging problem. Keep in mind, there was a reflection across the x-axis, so therefore our v is now upside down, and there was a reflection across the y-axis, so we kind of flipped it this way and we flipped it this way. All right, beautiful people, this has been your review for the absolute value for graphing. There will be a part 2 to this video, and we're going to talk about how to solve equations. Thank you for watching. Bye.